Welcome, my dear learners, to another interesting episode on this very channel. In today's lesson, we shall be looking at a new topic altogether, and that unit or topic is algebraic expression. Algebraic expression. But before we start our lesson, as usual, let's look at the lesson objective for the day. So, at the end of today's lesson, you, my students, should be able to add and subtract algebraic expressions together. You should be able to multiply binomial expressions. You should be able to factorize algebraic expressions, and you should be able to perform operations on simple algebraic fractions. These are our lesson objectives for this very unit. If you are new on this very channel, like, share, and then most importantly, subscribe to this very channel for more interesting episodes to come. So without wasting time, let's start. So we are starting with algebraic expression. Algebraic expression. Now in algebra, letters are used to stand for numbers. Now these letters that are used to stand in place of numbers are called variables. Variables. And letters which have fixed values are called constants. Constants. For example, when you have, let's say, 2 pi r squared h. Now, looking at these variables r and h are called variables because the values of r and h can be changed at any moment. You can get r to be 4, r to be 5, h to be 10, h to be 20. So we call r and h variables because their values can be changed at any moment in time. Now looking at 2 and pi. 2 and pi are called constants because they have fixed value. Their values cannot be changed. 2 is 2 and pi is still pi. So we call these 2 and pi constants. Now when we talk about algebraic expression, we are referring to a collection. So a collection of numbers, letters, and symbols combined with at least one of the operational signs. And we know the operational symbols or signs we have addition, subtraction, multiplication, and division. So when we talk about algebraic expression, it is a collection of numbers, letters, and symbols combined with at least one of the operational symbols. So when you have, let's say, 2x plus, let's say, 10y. This can be considered as an algebraic expression because it contains numbers, letters, and combined with at least one of the operational signs, which is addition. And then we have this. So this is a classical example of an algebraic expression. Another example of algebraic expression is 10wy minus 16qz. This is also an algebraic expression. We can also talk of, let's say, 25p yz minus 2x plus 10k. This is also a classical example of algebraic expression. I hope you can give examples of algebraic expression. Now, in algebraic expression, the terms within the algebraic expression are separated by the addition or the subtraction sign. So looking at this, we have an expression here, an algebraic expression. Now the terms in the algebraic expression are separated by an operational sign, addition and subtraction. So looking at this first algebraic expression, we have how many terms? So we have the first term and then the second term. So in all, how many terms do we have in this algebraic expression? We have two terms because we said that in algebraic expression, the terms are separated by addition or subtraction. And in this expression, we have what? Addition. So the terms are 2x and 10y. Now looking at the second example, we have 10wy minus 16qz. How many terms do we have in this example? We have two terms, that is 10wy and 16qz, because we said that the terms in algebraic expression are separated by addition or subtraction. I guess you are following. Now, how many terms do we have in the third example? We have 1, 2, and then 3, because we said that the terms in algebraic expression are separated by addition or subtraction. So we have the first term, the second term, and the third term. So I'm going to write one more example on the board and then determine the number of terms within that algebraic expression. Is that clear? Good. So determine the number of terms within this algebraic expression. Good. So how many terms are there in this very expression? So we have one term, 2, 3, 4, and then 5. We have 5 terms. What about this one? We have 1, 2, 3, 4, and then 5 terms, because we are saying that the terms in algebraic expression are separated by the addition or the subtraction. Now, a term contains numbers, letters, and powers. So looking at this is our first term. It contains what? Number and then letter. Now we'll look at this example 2. A term consists of numbers, letters, and then powers. So with the first term in this algebraic expression, it contains what? 15, which is a number, x, which is a letter, and then 2, which is what? A power or an exponent. I guess you are following this. So, in a term in algebraic expression, numbers comes first, followed by letters in an alphabetical order. So when you have, let's say, 15x, y. Now this is a term in an algebraic expression. The number must always come first, followed by the letters in an alphabetical order. So we can say that 15xy, but not xy 15. Now, the number must always come first. So we can say 17 x squared y z, but not x squared 17 y. In algebraic expression, numbers comes first, followed by what? The letters in alphabetical order. So when you are reciting your alphabet, S comes before Y comes before what? Z. That is how it is being arranged in an algebraic expression. Now, in algebraic expression, the number multiplying the letters or the variable are called the coefficients. Are called the coefficient. So we have the coefficient of x squared y z is what? 17. The coefficient of x and y is what? 15. Good. So the number multiplying the variables are called the coefficients. So when you have, let's say, 2x, 2 is called the coefficient of x, and then x is called what? The variable. Very good. Now when you have a, B, it means A multiplying B. So in algebraic expression, A times B is written as what? AB. Now when you have xy, this implies that x is multiplying y. So in algebraic expression, you will see xy, not x times y, but this means the same thing. Is that clear? Good. Also, you can have A over B. This means that A divided by B. So in algebraic expression, you'll be encountering A over B, not A divided by B. And A over B is the same as what? A divided by B. Is that clear? Good. Now that you understand some basic concepts on algebraic expression, let's look at what we call like terms and unlike terms. Like terms and unlike terms. Now, like terms. What is it? Now, like terms in algebraic expressions are terms that have the same variable factors. They have the same variable factors. So when you have, let's say, 2x and let's say 5x, these two terms are like terms because they have the same variable factors. That's what x and x. So these two terms are called like terms. Also, when you have, let's say, 10x squared and 15x squared. Now, these two terms are called like terms because they contain the same variables x squared and x squared. So we say that these two terms are like terms. Is that clear? Good. Similarly, when you have, let's say, 3x, y, z, and 3x and 7x, y, z. Now, these two terms are said to be like terms. Why? Because they contain the same variable factors. We have x, y, z, x, y, z. So we say that these two terms are like terms. I guess you are following. Now, what about unlike terms? Unlike terms. Now, unlike terms are terms that do not have the same variable factors. In other words, they have different variable factors. So, when you have, let's say, 2x and 5y, these two terms are unlike terms because they have different variables. We have x and then y, and x is different from y. So we say that 2x and 5y are unlike terms. Similarly, when you have 10xy and let's say 2wz, 10xy, 2wz, you realize that when you check the variables, they are different. We have xy and wz. So we say that this term and this term are unlike terms. I guess you are following. And I believe you can give examples of like terms and unlike terms. And when we are being asked to group like terms and unlike terms, you can do so. So let's make more progress by grouping an algebraic expression into like terms or unlike terms. Is that clear? Very good. So we have some few examples. We are going to group this algebraic expression into like terms and then unlike terms. So when we take the first part, we are going to group it into like terms and then unlike terms. So let's take the first example and then see how it goes. So we have the first one. So in grouping these terms into like and unlike terms, we said that like terms are terms that contain the same variable factors. So we are going to go through these terms one after the other and look at those with the same variables. The variables must be the same. So we have 4a squared. Do we have a squared somewhere? Yes, we have a squared here. So we can group this term and then this term. So we have 4a squared and then we have minus 2a squared. Good. Now we also have ab and then ab. So these two terms are like terms. So we can group them together. We have 3ab and then plus what? ab. Good. Very, very easy and then simple. Let's look at the next example. We have 3p. So let's look through these terms and see those having the same variable factors or the same variable. So we have p here and then we have another p here. So these 3p and then 2p are called like terms. Therefore, we can group them together. So we have 3p plus what? 2p. Now we have 5q and then q. They are also like terms and therefore we can group them together. Now try your hands on example C and then D. Let's do the C and then the D. Do it yourself. Is that clear? Good. So we have 2x plus 4x squared minus 3x plus 8x squared. So we have to group them to like terms. So we have x and then x here. So x and x are the same. So 2x and minus 3x are like terms. So we have 2x minus what? 3x. Then we have x squared. X with a power of what? 2 is different from x. This x with a power of 1. But this is x is a power of 2. So it's different from x. Take note of that. Okay. So we have x squared and x squared. So this and that are what? Like terms. Good. So we can group them together. So we have x squared plus what? 8x squared. And that is that. I hope and I believe you can group the last algebraic expression into like terms and unlike terms. This brings us to the end of today's lesson. If you are new on this very channel, kindly like, share, and then subscribe to this very channel. See you next week. Bye, 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 bye.